My name is Paul Cote, and I work at the Graduate School of Design at Harvard. My talk is very much related to what Chris has been talking about. If we get it together and use open, coherent, semantic standards for exchanging data, we can use Chris's data and he can use our data with a minimum of hassle. At the Graduate School of Design, we try to represent places to learn how they work and how they might work better. We're mainly users of data from the information infrastructure, but we aren't good at putting it back. And the reason is there are many tools involved in representing places, and the exchanges between these tools are very difficult to manage. There's always a lot of information lost when you go from one tool to another tool. If you're modeling terrain in Rhino and you want to bring it into 3D Studio, information's lost. What we need to do is come up with systematic ways of representing concepts and encoding that in a systematic way that we can all agree on and reuse. If we have systematic conceptual models of the important concepts and relationships that are important to us, we can not only serve our business processes better, but have predictable ways of getting data in and out of our programs and crossing programs between domains for interdisciplinary collaboration. It's all about having exchange encodings that our tools understand. Here's an example from city administration. Just talking with Jim Albrecht from the BRA. We've got all these departments using different tools that involve different concepts and relationships. What we need to do is get all of these different tools to talk to each other. Of course, this has been the problem for a long time, and we really need to get to work on this. If we can combine data from these different departments, we'll learn about the city and how it works. But we also have territorial domains spread out everywhere. Mike Turner solved this problem for City A, and he solved it in City B, but they've all got different data schema. We need to get it together so that we can combine data across different territorial domains and learn how the city works, the metropolitan area works. If we do that and we learn how to model the city and with shared conceptual models, we'll be able to compare the past situation with the current situation. Eventually, we'll be able to model possible scenarios and plan scenarios to understand urban mechanics and the consequences of our decisions. So here's a neat solution that's being developed right now and is a specification of the OGC. City GML has many concepts modeled at different levels of detail. So City GML is a framework for conceptual models that has different levels of detail for buildings, from coarse to interior spaces. There are modularizations in City GML that let you model terrain at different levels of detail, land use, vegetation. You can model the trees, you can model the forest, and also surfaces for transportation and circulation. In the next OGC Technical Committee meeting next week at Mountain View, they'll be working on networks for utilities and transportation. City GML is a modular framework so that different community groups can contribute their own important data schema and conceptual models to develop a consensus, and using foundation standards, develop exchange schema so that tools can interoperate with each other. Interoperable tools and stable standards will make it safe to create highly specialized tools that can share data, and will have a lot of interoperable content, and we'll learn about the city more effectively. So let's get it together. We should all be aware of these open standards for interoperability, and we should demand interoperable standards from our tools and build them into our administrative infrastructure. Here's some references. City GML is being developed by the OGC and a bunch of people from Germany.